Hello, pre-calc students. Going over 2.01 functions, the first section of the pre-calc final review packet. So the first function is linear, and it should have a standard form of y is equal to mx plus b. Where m is the slope and b is the y-intercept, and it should have a domain from negative infinity to infinity, and also have a range from negative infinity to infinity. For the power / polynomial function, this should going to be in the form an x to the n plus an minus 1 x to the n minus 1, and then we'll continue to a2 x squared plus a1 x to the 1, then just plus a0 x to the 0, where a is going to be a constant and x is going to be x, and then you have a descending exponent. So an example here would be like 3x to the 4th minus 0x cubed plus 2x squared plus 3x minus 4. So that's an example. The domain of a power / polynomial, domain of a polynomial is always going to be all real numbers, and the range is going to be if the degree is odd, then the range will be all real numbers, and then if the degree is even, the range will vary. So if you have an even degree, then the range will vary. For an exponential function, this is going to be the form y is equal to a times b to the x power, where a is your starting value and b is the term, the growth or decay factor. The domain of an exponential function is going to be from negative infinity to infinity, and the range of a exponential is going to be the vertical shift to infinity. So the range will vary. But one way to look at this is, if you look at this a times b to the x plus k, you could look at this as the range is going to be from k to infinity. Well, I don't want to make it too many statements. Let's keep this as varies. Logarithmic function, y is equal to the log base b of x. So the domain is going to be, the logarithmic function is going to be should be from 0 to infinity, but this can vary. And then the range should be from negative infinity to infinity. The rational function is going to be equal to a polynomial over a polynomial, and the domain is can vary because there's different values that we could divide by 0. So you can't divide by 0. And the range of a rational function is also going to vary because of horizontal asymptotes. For a piecewise function, The piecewise function is going to be, you have different functions on different intervals. And so with the piecewise function, the domain, the range, they will very much vary and vary. And for the greatest integer function, it should look something like x, and so the range of the greatest integer, the domain should be all real numbers, but the range should be all integers. All right, so 2.01 multiple choice practice. Let's get into the practice problems. What value of x satisfies the equation log base 4 of 2x plus 8 equals 3? So what we first have to do is we need to swoosh the logarithm to get the x out of this parentheses. So you have log base 4 of 2x plus 8 equals 3. Swoosh the logarithm. So 4 to the third power, swoosh across the equal sign, is equal to 2x plus 8. And so then I can say that 4 to the third minus 8 divided by 2 is equal to x. If I subtract 8 and divide by 2, that will get me x. So with my calculator, I can do 4 to the third, which is 64, subtract 8, divide by 2, and x is equal to 28. So question 1 is answer choice C, 28. For problem 2, a company's profit function is given by the function p of x is equal to negative 3x squared plus 18x, where p of x is a profit in dollars and x is the number of units produced in thousands. Assuming the company wants to maximize profits, how many units should they produce? So we know that, first of all, we know that p of x is a parabola and with the parabola, the vertex will represent, the coordinates of the vertex will represent the units produced in thousands to maximize profits, and then maximize profits. So how do we find the vertex? Well, we can graph the function and then find maximum. So we graph the function negative 3x squared plus 18x. Change our window. So our y max is, let's say, 40. We're going to calculate our maximum. We calculate a point to the left of the maximum. We calculate a point to the right of the actually a point to the right of the maximum. And then we take our best guess, our vertex. So we put function in the calculator. So our vertex is at 327. So because 3 is the number of units produced in thousands, you produce 3,000 units to maximize profits. Produce 3,000 units to maximize profit. So the answer choice is B for 2. Moving on. The temperature degrees Fahrenheit of the water in large fish tank is modeled by the function T of x is equal to the natural log of 1 plus x plus 52.4, where x is the number of pebbles in the tank. Approximately how many pebbles are in the tank if the water is 58.3 degrees Fahrenheit? So the pebbles in the tank determine the temperature, but we need to figure out how many pebbles in the tank when the temperature is 58.3. So what we'll have to do is use the equation. 58.3 is equal to the natural log of 1 plus x plus 52.4. And our first step is to subtract 52.4 because we're trying to isolate x. So 58.3 minus 52.4. That value will be 5.9. So 5.9 is equal to the natural log of 1 plus x. Side note, the natural log of x, that's equal to the log base e of x. So that will help us swoosh our logarithm. So if 5.9 is equal to the log base e of 1 plus x, then we can swoosh our logarithm and say that e raised to the 5.9 power is equal to 1 plus x. Subtract 1. E to the 5.9 minus 1 is equal to x. So we, in our calculator, we e to the 5.9 power minus 1 is going to be equal to x. And that means x is going to be equal to 364, which is closest to 360, meaning answer choice A is the correct answer. Moving on, problem number 4. What is the domain of the function given by f of x is equal to x squared minus 3x plus 2 over x squared plus 2x minus 8? So we need to find the domain of the function, and the whole idea with the domain is that you cannot divide by 0. So you can't divide by 0. So we need to factor the numerator and the denominator. The numerator can factor, we need two numbers that add to negative 3 and multiply to positive 2. So the numerator will factor into x minus 2, x minus 1, and the denominator will factor into two numbers that multiply to negative 8 and add to positive 2, and those numbers are going to be x plus 4, x minus 2. And these two values cannot be equal to 0, so this is going to set up two equations because we can't divide by 0. X plus 4 cannot be equal to 0, so x cannot be equal to negative 4, and x minus 2 cannot be equal to 0, and x cannot be equal to 2. Alright, so then you have a domain from negative infinity to negative 4, union, negative 4 to 2, union, 2 to infinity, because this is all numbers except for negative 4 and positive 2. So that is answer choice C. So the main goal here is to factor this, and then note that if any of these terms become 0, then the whole denominator, you're multiplying by 0, making the denominator 0. So you can't do that. So these are values that x cannot be equal to, and we express that in interval notation in this way. A ball is thrown such that its height is modeled by the function h of t is equal to negative 4.9 t squared plus 40t plus 2, where h of t is the height in meters and t is the time in seconds after the ball is thrown. After how long will the ball reach a height of 50 feet for the first time? So what means that the height is 50 feet, and this is the function. This is demonstrating the function. So what we need, this is the equation that we start out, is 50 is equal to negative 4.9 t squared plus 40t plus 2. And a skill we can use is that we can plug this in as one function and plug this in as a second function, and then use the calc intersect to find our function values, okay? So the first function can be y1 is equal to 50. The second function can be y2 is equal to negative 4.9, and here our variable is x squared plus 40x plus 2. Oh, I need to change my window here. Because I need my y max. Going to make my y max 60 so I can really see the intersection here. So that's the y max. This is the function, and I'm looking for when the function hits 50 the first time, not the second time, but the first time. So I need to find the intersection. So calc intersect, that's choice number 5. And this is the first curve in blue. The second curve in red. My guess for the intersection. It's my best guess for the intersection. So the intersection is at 1.4650. So the intersection is at 1.46 comma 50, and so the answer choice is A, 1.46. What value of n would make the function continuous? So we're going to call this piecewise function 1, 2, and 3, and so piecewise functions 1 and 2 meet when x equals 1, and 2 and 3 meet when x equals 3. This is when 1 and 2 meet. This is when 2 and 3 meet. And so the function is continuous when the f of x has the same y value when meeting up, when touching. So let's apply this. You will have x squared plus 1 is equal to n. And then when you plug in function 1, function 2, remember x is equal to 1, so you'll have 1 squared plus 1 is equal to n, so 1 squared is 1, plus 1 is n, so n is equal to 2. So let's look at it again for question 2 and 3. 5 minus x is equal to n. Function 2 and 3 meet when x is equal to 3. So 5 minus 3 is equal to n, so n is equal to 2. In this case, in both scenarios, n is equal to 2, so the function can be made continuous. And that's by when n is equal to 2. That would make the function continuous. For problem number 7, which expression is equivalent to x minus 1 over x plus 2 plus x plus 2 over x minus 1? And our goal here is to get a common denominator to add fractions. Add fractions. To add fractions, you need to add fractions with a common denominator. So you will have x minus 1 over x plus 2 plus x plus 2 over x minus 1. And the goal here is to multiply by the other common denominator, so you will have to end up with the same denominator. And if you multiply by the other denominator over itself, you'll still be keeping the fraction, the rational function equivalent. So you multiply this by x plus 2 over x plus 2. Multiply this function by x minus 1 over x minus 1, and you're going to distribute throughout. So you will get x times x is x squared times x times negative 1 is negative x plus x times negative 1 is negative x. So x squared minus x. So that's going to become minus 2x. X squared minus 2x, negative 1 times negative 1 is plus 1 over x minus 1 times x plus 2. So that's going to be x minus 1 times x plus 2. That's going to be x squared plus 2x minus x minus 2. So that's going to be x squared plus x minus 2 plus x times x is x squared plus 2x plus 2x plus 4x plus 4 over the same denominator, x squared plus x minus 2. And we can combine that like terms. X squared plus x squared is 2x squared. Negative 2x plus 4x is 2x. And 1 plus 4 is 5. And then you have the same denominator, x squared plus x minus 2. And so do we have a 2x squared plus 2x plus 5 over x squared plus x minus 2? We do. That is answer choice D. All right. So that's problem 7. Which function is always increasing on the interval from negative infinity to infinity? So you have f of x equals x squared, if we know what x squared looks like. X squared looks like this, it's a quadratic. But here, on this interval, it is decreasing, so that's not the case. For the log base 2 of x, the log base 2 of x is going to look like this function right here. And so, while increasing on all intervals, it is not increasing. The log base 2 of x is not increasing from this interval from negative infinity to 0. The function doesn't exist from negative infinity to 0. For answer choice C, 2 to the x, however, 2 to the x, that function is an asymptote up until it, gets to the positive x values, but it still is ever slightly increasing, and then it's going to keep on going up forever. And so this is increasing from negative infinity to positive infinity. So that's going to be 2 to the x. And it's not going to be d because negative x cubed, that graph looks like that. So that graph is always decreasing. Is always decreasing. All right. Moving on to question 9. What are the end behaviors of the function negative x cubed plus 3x squared plus 2x plus 2? Negative x cubed plus 3x squared plus 2x plus 2. Well, you have a odd degree and a negative leading coefficient. And all polynomials with an odd degree and negative leading coefficient is going to have end behavior that will look like this. So hopefully you can see as x approaches negative infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches positive infinity. So it's going to be d or b. You can also see that as x approaches positive infinity, f of x approaches negative infinity, going down. F of x, and then x approaches positive infinity, f of x approaches negative infinity. So the answer choice is going to be answer choice D. And you can also graph the function and just see it has this end behavior. But you got to be able to know this based on the end behavior rules, and you just got to know it intuitively. That's problem 9. Problem 10. The value of a car depreciates 9% each year. Depreciates 9%, that means multiplied by 0.91. The car was bought for $12,000 at the beginning of 2018. In what year will the car be worth only $5,000? This is an exponential decay problem. So any exponential decay problem is going to be f of x is going to be equal to a times b to the t, where f of x is going to be your amount after, a is your initial amount, b is your decay factor, and t is time, usually in years. So setting this up, 5,000 is equal to 12,000 times 0.91 to the t power. And so that means 5,000 divided by 12,000 is going to be equal to 0.91 to the t power. And so then converting between exponentials and logarithms, the log base 0.91 of 5,000 over 12,000 is going to be equal to t. So the log base 0.91 of 5,000 divided by 12,000, that's going to be equal to t. So t is going to be equal to 9.28. And if you're in the year 2018, add 9.28 years. So add this to 2018. And we are in the year 2027.28, which is going to round out to 2027. What is the solution set to x plus 3x over x minus 1, which is equal to x plus 2 over x minus 1? Well, let's divide. So we will have x over x minus 1, and we're going to also have to multiply by x minus 1. So I'll show you what we're doing here. What we're doing here is we're taking that x, and we're multiplying that x, think of that as x over 1, by x minus 1 over x minus 1 in order to get a common denominator, plus 3x over x minus 1 is equal to x plus 2 over x minus 1. So we multiply across, and we can get x squared, x times x is x squared minus x plus 3x all over x minus 1, because we now have a common denominator, is equal to x plus 2 over x minus 1. And then we can combine like terms again, where this will, we can subtract an x, and subtract a 2. So you will get x squared plus 2x minus x, so x squared plus x minus 2 all over x minus 1 is equal to 0. And then multiply each side by x minus 1. So this will cancel out, and this is still 0. And so you'll have x squared plus x minus 2 is equal to 0. Factor this. This will be x plus 2 x minus 1 is equal to 0. And the reason why is because two times negative 1 is negative 2, and 2 plus negative 1 is positive 1, because remember that's a 1x. And so set these equal to 0. That means that if x plus 2 is equal to 0, then x is equal to negative 2. So that's one option. And then you would think that if x minus 1 is equal to 0, x is equal to negative 1, or x is equal to positive 1. But if x equals positive 1, then you're going to have a situation where you would divide by 0. And that's not okay. So x cannot equal positive 1. So x cannot equal positive 1 here. X can only equal negative 2. So as soon as we see the x minus 1, we can make the statement x cannot equal positive 1. And so we can actually, just at looking at the problem initially, we can eliminate answer choice C. So the answer choice is B. X is equal to negative 2. You can also try plugging this into your calculator. That would work just fine. If you All right, so that's problem 11. Problem 12. A computer company charges $50 to rent a computer for 1 week. The table below shows the daily late fees and the company charges if a computer is returned late. Days late 1 through 10. the late fee is $5. 11 through 20, the late fee is $8. 21 through 30, the late fee is $10 per day. So, first of all, if you rent the computer, it's going to cost you $50 initially. Then, for the first 10 days late, so for days 1 to 10, it's going to be from day 1 through day 10. You're going to have a late fee of $5 a day, so that's 10 days. So you have a late fee of $5 per day times 10 days. So your late fee is going to be another $50. And then days 11 through 20, the daily late fee is $8. So now you're going to have late for days 11 through 15. So you're going to have day 11, 12, 13, 14, and 15. So that's another 5 days. So that's $8 a day times 5 days. So 5 times 8 is 40. So that's going to be plus $40. So 50 plus 50 plus 40 is equal to $140, and that's answer choice C. So that's problem 12. For problem 13, James has a rectangular piece of cardboard that was 4 times as long as it was wide. So this length right here is 4 times as long as it's wide. So if I can call this length 4x, I can call the width x. Also know that the 3 by 3 square is cut out of each corner. So this square has a length of 3, this has a length of 3, has a length of 3, has a length of 3. These all have a length of 3. And you're going to fold this box up so that this is going to be the base of the box. So this will be the length of our cardboard box when we fold it up. So when you fold it up, you're losing this. So you're losing 3 on this side and this side. So our new width is going to be our width is going to be x minus 6, because that's x minus 3, taking away this 3, taking away this 3 as well. And our length will be 4x, but we're taking away a 3, and we're taking away a 3. So our length is going to be 4x minus 6, and the height is going to be 3, because when we fold this corner up, the height is going to be 3. And so volume is going to be equal to length times width times height. But that says the volume right here is 336 cubic inches. So the length times width times height, that's equal to 336. So the volume is the length, which is 4x minus 6, times the width, which is x minus 6, times the height, which is 3. And that's all equal to 336. And so this is an equation we can plug into our calculator. If we just change our window so that let's make our x min -2 or x max 13, and we want to just make our y max, because this goes all the way up to 336. Let's make our y max 400. Let's plot our equation where One equation is 4x minus 6 times x minus 6 times 3. The other equation is 336. And we should see, when we calculate the intersection, that we're going to go to Calc, Intersect, the first curve. Sorry about that. The first curve is the blue curve. The second curve is the red curve. And our best guess is the intersection of the two curves when x is a positive length. So the intersection is when x is 9.5 and y is 336. So the correct answer is B, 9.5 inches. So we put this in the calculator as y1, put 36 in the calculator as y2, and we can solve for x. So we need to solve for x. We use Calc, Intersect. So that's 2.01. Have a great day.